In this video, I'm going to talk about how to exploit Stack Overflow with a simple example. Let's take a look into the code. We have function start, which contains a buffer of 128 bytes. Then we use sprintf to copy the argument into the buffer. Lastly, we print out the string. At main, we can input up to 1024 bytes and pass our input to function start. This creates a Stack Overflow vulnerability. The reason why I added jump ESP into the program is because most of the Windows back to early 2000s have this piece of instruction directly or indirectly within the libraries. Let's put this piece of code into a debugger and see what the stack is like. Once the program is loaded, let's breakpoint at start and the last instruction. Let's disassemble function start first. And we have the address of the return instruction. Break. Remember, we can input up to 1024 bytes. So what if we overflow the program with some random bytes? I would like to introduce pattern create in Metasploit, which you can generate random string with the length you want and pinpoint the offset. Let's set the length to 1024. Now we have the string and echo it into a file for later usage. Let's input the string into the program and see what happens. As you can see, at the early stage, when the star is called, we can see the return address points back to main, which is the next instruction of the function called start. Take a look. This address points to here. It's the same address, and this instruction is right below the function call. Now let's continue. Now, as you can see, the return address gets overwritten by my input. Take a look at this address, ffffcdfc. This is the address where the return address was originally stored. So we can use the string here, 6A-E7, to find out the offset from our input to the return address. We use pattern offset from Metasploit. And now we have our offset of 140. Now let's make the return address point to jump ESP and make our exploit. When it comes to shellcode, I usually go to exploit.db and find my own piece of shellcode, which saves a lot of time. If you wonder what it is, it's a piece of assembly code that generates a shell. And the offset is 140, so we have A with 140. And the return address is the address of the jump ESP. Oops. We still have to figure out what's the address of jump ESP. So let's fire up our GDB again. Disassemble jump ESP. So this is the address. P32, the address, and we start the process first, and send our payload of shellcode offset first plus the return address and the shellcode. P dot interactive. And let's run this exploit, see if it works. There you go. Thanks for watching the video, and until next time.